In this video, we are going to learn how to create, program, and test a structured text routine. Structured text is a textual programming language that uses statements to define what to execute. ST is not case sensitive, and it is recommended to use tabs and carriage returns, separate lines, to make your structured text easier to read. They have no effect on the structured text. Let's start by creating an ST routine. Right-click on the main program and select Add New Routine. Assign to the routine a unique name and make sure that the type is structured text. In this example, our routine will be the main one. Click OK to create the routine. The main routine has been created. Let's open it. The ST editor is now ready. Recently, new important features were introduced to this editor, and over this video we will have the opportunity to see them. The first two features to mention are the magnifier and the inline value display. The icons are easily spottable on the editor toolbar. The ST programming language supports the following constructs and iteration loops: if-then and case-of constructs for do, while do, and the repeat until iteration loops. To demonstrate the mentioned constructs and iteration loops, we are going to create 4 additional ST routines. Each routine will be used to demonstrate a specific construct or iteration loop. For instance, the routine that we are now creating will contain some code to demonstrate the if-then construct. The routines have been successfully created. The main routine will be used to demonstrate the case-of construct. Let's start now by entering some code to the routine called st4. The magnifier tool allows us to zoom in and out the code of the routine. Before coding, let's introduce some important definitions. Assignment. Use an assignment statement to assign values to tags. The equal operator is the assignment operator. Terminate the assignment with a semicolon. An expression is part of a complete assignment or construct statement. An expression evaluates to a number, numerical expression, a string, string expression, or to a true or false state, bool expression. During the video, we will have a closer look on tag expressions, immediate expressions, operator, and function expressions. Let's pass now to the for-do iteration loop. By entering the word for, a tooltip provides us with the definition of for loop. Instead of typing the entire iteration loop structure, we can use a brand new ST editor feature called code snippet. A code snippet is a pre-configured structure intended to assist the programmer in achieving correct syntax for the particular structure. Since the do loop is a pre-configured code snippet, by pressing the tab key, Logix will generate the for do structure automatically. However, in this case, 3 fields have to be configured: the count tag, the initial, and the final values. Count tag is tagged to store count position for the for do executes. The initial value specifies initial value for count, and the final value specifies the final value of the count, which determines when to exit the loop. For example, let's set the initial value to 1 and the final value to 10. The count tag has already been created. When enabled, the for instruction repeatedly executes the statements within the loop until the index value exceeds the terminal value. Each time the for instruction executes the statements within the loop, it adds the step size to the index. Do not loop too many times in a single scan. An excessive number of repetitions causes the controller watchdog to time out and causes a major fault. Let's define a simple numerical expression. The value of counter will be increased by 1 each loop iteration. According to this code, the math formula will be executed for 10 times. Bear also in mind that this routine is part of a continuous task, so when we will test the code, the value of counter will increase quickly. We have just seen the for-do iteration loop. Let's see now how the while-do iteration construct works. We are going to open the st while routine. By typing while, Logix again shows us the tooltip with the information about this iteration loop. Press the Tab key to generate automatically the iteration loop code. Use the while-do loop to continue performing an action while certain conditions are true. The controller first evaluates the bool expression. If the condition is true, then the controller will execute the statements within the loop. The while loop is being executed as long as the bool expression is true. Let's define a correct bool expression. We make a comparison between the value of a tag named value and 1000. As long as a value is less than 1000, the controller will execute the loop. By the following math formula, we will increase the value by 1 each time the loop is executed. We can easily understand that this loop will be executed at least 1000 times. Let's pass to the repeat until loop by opening the st repeat routine. We are going to use again the code snippet feature to create the iteration loop structure. Use the repeat until loop to continue performing an action until conditions are true. Repeat loop checks the condition at the end of each iteration, whereas the while loop checks it at the beginning of each iteration. So repeat loop executes at least one iteration, whereas while loop may not execute any iterations if the condition is not fulfilled. Let's enter now a valid bool expression. We compare the value 1 with 1000. As long as value 1 is less than 1000, condition false. The controller executes only the statements within the repeat until loop. When the bool expression is true, the controller executes the rest of the routine. As we have done for the other iteration loops, let's add a math formula that will increase the value 1 by 1. When the controller executes this code, first the value 1 will be increased by 1, and then the repeat loop will evaluate the bool expression. So far, we have seen all the available st iteration loops. Let's pass now to the if-then construct. To demonstrate the if-then constructs, this time we will not use the code snippet. Use if-then to complete an action when specific conditions occur. According to the code that we have developed so far, we can use the if-then construct to reset the value of the tags used within the iteration loop. Let's first reset the tag named counter when its value is greater than 1000. When the counter value is greater than 1000, the controller will assign 0 to the counter. Remember, when dealing with constructs or iteration loops, it is always mandatory to mark their termination point by typing the word end name of the construct or iteration loop. Let's see now the collapsible feature. When our code becomes fairly lengthy and messy looking, the collapsible feature allows us to collapse a specific construct or iteration loop and make the routine more readable and cleaner. Clicking the minus sign next to the if instruction, it is possible to collapse this construct. Also, notice the ellipses to the right of the collapsed construct. These allow you to peek into the construct without having to expand it. The ST editor offers the chance to include comments to the code. By typing //, it is possible to add some comments or a description of the code. Let's complete this routine. We want to reset the tags used for the iteration loops when specific values are reached. Our code is completed. We can see from the line number 11 that it is also possible to add some comments to the code by entering the characters /* and */. As an example, the second construct contains a small bug. This will allow us to demonstrate how the code works while online with the controller. We can now pass to the case of construct. Let's open the main routine. Let's start by typing the word case and then press the Tab key to generate the construct code. Use case of to select what to do based on numerical value. With the case construct, the controller executes only the statements associated with the first matching selector value. Execution always breaks after the statements of the selector and goes to the end case statement. Beside the main routine, we have 4 other routines, and we will use the case of to call one routine at a time. We will replace the numeric expression with a tag named selection. Based on the value of the selection, one routine at a time will be invoked. For instance, when the value of selection is 1, we want to call the routine st4. We will jump to the routine st_while when the value of selection is 2. To jump the st repeat routine, the selection value has to be equal to 3. To call the last routine st_if, we are going to see a different way to define the selector value. In fact, using the case of construct, it is also possible to define a selector range value. When the selection value is between 4 and 10, then the st_if routine will be executed. So far, we have developed some code to demonstrate the construct and iteration loops supported by the ST programming languages. We can finally download this project to the controller and see how the code works. Our controller is in run mode. We can now test our structured text routines. Enabling the inline value display feature, Logix Designer will show us the live values of tags. As explained previously, we are going to change the value of selection to execute the other routines. Let's set the value of selection to 1 and then press enter. After entering this value, the routine named st4 will be executed. Every scan, the for-do iteration loop executes 10 times the math formula. This is why the counter value is increasing rapidly. To demonstrate further, we are going to change the value of selection to execute the st_while routine. According to the case construct, by setting the selection to 2, the routine st_while will be executed. In the first iteration, the initial count value was 0, and the while loop could increase the count value by 1. When the count value reached 1000, the while bool expression became false, and the controller could move forward. Let's see now how the repeat loop behaves. By setting the selection value to 3, the st repeat routine will now be executed. The repeat loop executes its statements and then evaluates the Boolean expression. This proves the fact the value 1 is continuously increasing. The last demonstration is about the st_if routine. Let's see the selection to a value between 4 and 10. As mentioned previously, this routine has the goal of resetting our tags. Counter and value 1 tags are now set to 0. We can also see from the line 7 that the bool expression of the if construct is not met. In fact, value tag is equal to 1000. The bool expression is true when the value tag will be greater than 1000. Let's fix this bug by editing the routine. When in edit mode, let's change the relational operator from greater to greater equal. After finalizing the online edits, the code works properly. We have seen together how to create, program, and test structured text routines. This kind of programming language is suitable for complex mathematical formulas and data handling.